Hi everyone, thanks for joining today's event, Selenium 3.0, the Spec and onwards. My name is Adi and I'm the event's moderator. First of all, let's make sure the sound is working. So if you can hear me, please use the raise your hand option in the control panel on your right. So show of hands if you can hear me. Okay, great. Sound is working. Today's speaker is Simon Stewart, Selenium Project lead and the inventor of WebDriver. Just before Simon kicks off the webinar, a few important things to keep in mind. Feel free to ask questions during the webinar. You can do that in the GoToWebinar control panel on your right. We will try to answer as many questions as possible at the Q&A session at the end. The webinar is recorded and the link to the recording will be emailed to you tomorrow. For optimal viewing experience, I recommend you close off any unnecessary apps running in the background. And if you encounter any technical issues, please send me a private message in the chat room, also in the control panel, and I will try to take care of it as soon as possible. So now, Simon, the stage is yours.
Wow. Hello, everybody. I can see there's lots of you out there. Thank you very much for giving up your time to come and attend and listen to this talk on Selenium 3.0 forward. I think it's going to be lots of fun. I've been told that there are lots of people listening, and particularly a group in Belfast who have got a meetup and they're all listening. So hello Belfast and welcome everybody. So I'm going to be speaking for about 45 minutes, and then afterward there's going to be plenty of time for questions, as Adi said. So feel free to just type your questions and we will get through as many of them as we can at the end as humanly possible. So the feature presentation, the thing you're here for. This is a talk about Selenium 3.0, and I think the best way to begin is to go all the way back to the past, where we came from. This is, of course, a 1950s robot, which has absolutely nothing to do with Selenium. But I like the picture, so there you go. Let's go back to ThoughtWorks, which is the company that Jason Huggins was working for when he had to work on their new time and expenses application. ThoughtWorks is an agile IT consultancy, and the consultants need to book the time on their project and put their expenses in every month. At the time, everyone was using Lotus Notes, which was slow and cumbersome, so they were working on a new web application that would allow them to do this. The problem is that everyone had a different browser, and Jason, as he was working on this, would fix one bug, only to have it rise up in a different browser. So it would be fixed in Internet Explorer, but it would be broken in Firefox. He'd fix it in Firefox and something else would break in Internet Explorer. He'd fix it in both of them and Opera would no longer work. It was a real headache. And because it was an internal project, there weren't many people available to help him do QA. At around this time, he saw the work of Ward Cunningham and FIT, the functional integration testing. And the simplest way to describe what FIT was it was table-based. There were HTML tables, and in the left-hand column was some sort of action, and in the columns beside it were the values that you were expecting to see or were going to input. Jason took this idea and realized that the problems he was experiencing were because the web browsers were all running JavaScript. Well, maybe he could use JavaScript to control the web browser itself. And so Selenium Core was created. Selenium Core was essentially a very complicated JavaScript application that ran within the context of the browser. And this meant that it could manipulate the DOM, it could simulate clicking, it could do all sorts of things. Obviously, this first version was based, as I said, on Ward Cunningham's work on FIT, functional integration testing. And so tests were all written as HTML tables. I don't know about you, but I'm a software developer And I like writing software in code and not in HTML tables. They're cumbersome, they're hard to use, they're not particularly friendly. They're incredibly hard to refactor. There are any number of reasons why what you would want to do is take this Selenium core and run it with a programming language. So when Selenium 1.0 shipped, there was a mechanism called remote control, Selenium RC, which for a long time was the main way that people used to automate their browsers. It was an excellent mechanism, and it was enabled by the work of Paul Hammond, Dan Fabulich, and a group of other people. Essentially what happened was you used the programming language of your choice to talk to a server process that was running on your local machine, and that server process streamed the commands to a browser using Selenium core. So you were still interacting using the original JavaScript technology. About a year and a half, 2 years after Jason started Selenium and wrote Selenium core and Selenium RC, I was also working at ThoughtWorks, and I was having a conversation with a colleague. At the time, our main testing tool was HTTP unit, which was a pure Java implementation of a web browser. And that web browser was rubbish. It could do almost nothing. It didn't run JavaScript, but that was fine because this was Web 1.0, and web pages would reload completely every time you interacted with them, and the process was slow and cumbersome. The problem with HTTP unit that my colleague mentioned was that it was in gross violation of the basic principles of object orientation. That is, when you looked at the API, it mashed together making assertions about the state of things, finding elements, navigating around, and things like that. It was it was an API that was designed for use in tests and didn't really attempt to be pleasant or aesthetic. My friend and colleague was saying that what we should really do is put some wrappers around this. And over the course of several projects, this is exactly what I did. I put wrappers that were slightly more object-oriented around HTTP unit, and when it became available, I would switch the underlying implementation from HTTP unit to the newer, nicer HTML unit. This was going great, and I did this about 6 or 7 times. I then landed on a project with a friend of mine called Joe Warnes. Joe had also been going through a similar process. I had ended up with 2 interfaces that encapsulated most of the behaviors that I wanted, one called Web Element and one called Browser. Joe had ended up with Element and WebDriver. I thought the name WebDriver was awesome, and so with Joe's permission, I borrowed the name, and we used that and essentially my browser API for the testing on the project. It was all pretty good, and we proved to ourselves that it worked nicely, but the project came to an end. While I was waiting for a new project at ThoughtWorks, I did a clean room implementation. So I sat down and using the experience that I gleaned from several projects at ThoughtWorks, wrote a fresh version of the WebDriver APIs. The idea with this was that I would just write this one time, and then because it was open source, we'd be able to use it on any project, and because we could use it on any project, it would be done very quickly. I was thinking, and this was in 2007, that I would be done in a year, maybe 2 at the tops. So where are we now? Well, we have Selenium 2. We bumped the version number because not only did we have Selenium Core and Selenium RC, but we merged in WebDriver. This was the result of Jason Huggins and myself meeting at Google, where we were both working. Jason was trying to figure out how to solve a series of problems that Selenium RC and the core implementation were running into. At the time, things like Ajax were becoming popular. Google Maps had launched and were demonstrating that you could do very impressive things using JavaScript in the browser. The problem with that was that you needed greater fidelity of user emulation. That is, when there was a click, it wasn't enough just to fire the click method on the DOM. You had to also simulate the mouse down and the mouse up and the mouse press and all the other bits and pieces. And that was proving incredibly challenging. Worse than that, the Selenium core implementation was running inside the JavaScript sandbox. Now the sandbox is there to prevent people from accidentally causing mayhem and chaos, and it's to keep your browser secure. You can imagine that automating a web browser is possibly the least secure thing you can do with it. And so what was happening was, as the web applications were becoming more sophisticated, it was becoming harder and harder to emulate what needed to be done. WebDriver, on the other hand, had taken a different approach. I had, somewhat foolishly, I will admit, Paul Hammond used to call me an idiot for doing it. I had integrated tightly with each web browser. That is, for Firefox, I'd written an extension which meant that the WebDriver code was running with elevated privileges and could do things like break out of the JavaScript sandbox. With Internet Explorer, we'd wrapped the common components that were part of the operating system and IE itself. Like, if you're familiar with Internet Explorer, the thing that you call a web browser is actually a collection of these COM components that have all been wired together. And WebDriver for IE basically poked those directly, and again could do a series of things that were impossible to do in pure JavaScript. So merging the projects solved some of the technical problems that Jason was having, and allowed me to get the WebDriver APIs in front of a larger audience. And so we released Selenium 2.0. So once you've done Selenium 1, which was the original Selenium core implementation in RC, and Selenium 2, the logical thing to do next would be to release Selenium 3. Selenium 3, I foolishly promised once by standing up on stage and announcing that we would release it by Christmas. And I think this was about 3 years ago now. Fortunately, I never said which Christmas it was going to be. And so although we've missed several Christmases since then, everything is still on track. One of the nice things about working for an open source project is you can release it when it's done. So we will pick a Christmas, and it will be out by that particular Christmas when it's all finished. I have a question for you, and this is probably why you're attending this webinar, and that is, what on earth is Selenium 3? What will be in it, and why are we bumping the version number from 2 to 3? The main thing that you're going to see in there is that the original Selenium core implementation is going to be retired, and all that will be left will be the current WebDriver APIs. That sounds like either a massive change or a minor change. For the past 5 or 6 years, we've been advising people who are picking up Selenium to take advantage of the WebDriver APIs instead of Selenium core. So hopefully, most of you are already writing your tests using the WebDriver APIs. For those of you using Selenium RC, we have a number of pieces of technology which we are putting in place in order to try and support you, and I will talk about those later. But the major reason why we're bumping the version number is because the original Selenium core mechanisms are being retired, and we're just leaving the WebDriver APIs present. The reason why we're retiring the Selenium core APIs is an implementation is largely because it's becoming increasingly difficult to test modern web applications using just a pure JavaScript approach. And rather than have something that is slowly becoming harder and harder to use, what we would like to do is offer something that is rock solid, incredibly capable, and can do all the things you want to do. So what does it mean for you? The main implementation where the Selenium core code lives is tucked away in the Java bindings. What you're going to see with Python and Ruby is essentially no change. You will still have the WebDriver APIs available, but not the RC ones. And in .NET, the old RC APIs are going to be left. But Java is different. Java is where that server component that I talked about used to live. So what are we doing with Java? We're breaking it up into 3 separate libraries that you can download. If you just update the version number of Selenium from 2.something-or-other, 5.3 to 3.0, what you will get is the current Selenium Java. That will be just the WebDriver APIs. You won't get Selenium RC, you won't get the old Selenium interface, you won't get default Selenium. But you will get WebDriver, and if you add the dependencies for Firefox and Chrome, you'll be getting those as well. At the same time, what we will do is add a Selenium 3 server, a new lightweight implementation, which I like to think of as being pin compatible. If you go back to the early days of the x86 processors from Intel, Intel were the only company that made anything that was able to run x86 code. And then AMD came along and they did an implementation of the x86 instruction set and created a chip that would sit in the same CPU holder but had a completely separate implementation. And it was called pin compatible. So you could drop in one of these non-Intel CPUs into a motherboard expecting an Intel CPU and everything would continue to function as it should, despite the fact that you had a completely different implementation. The goal with the Selenium 3 server that we released is that you will need to make minimal changes, or ideally none, to the way that you start the server. Certain options, for example, setting whether or not the server is used as a proxy, will be ignored, and we will flag those to the logs. But your tests should continue running just as they should with this new lightweight server. Now, lots of you, in fact, every year at Selenium conference, there's always a talk about someone or a company that have made an absolutely gargantuan investment, a very large investment in the tests using the original Selenium RC API, so the Selenium interface and the default Selenium implementation. We don't want you to throw away those existing tests. That would be an unfair and cruel thing to do. But we can't continue to support the original Selenium core implementation. So how do we enable you to maintain your existing investment in tests while at the same time moving the state-of-the-art forward? What we are going to do is introduce a new dependency that you can take for your projects, which we have named LegRC, because it sounds a little bit like legacy. This is one of the reasons why the project team don't let me name things very often, because I like a bad pun. The LegRC package, the legacy package, will contain, certainly for Java, the current Selenium interface and the default Selenium class. So provided you're not relying on parts of the server itself, if you're just using the Selenium API, picking this up will allow your implementations to compile and run. Included in that legacy package will be a WebDriver backed Selenium. So that's an implementation of the existing Selenium APIs and Selenium APIs extended from default Selenium. So inheritance will work and you won't need to rewrite things. But it will be backed by WebDriver rather than Selenium core. It's Java, right? So of course we have an incredibly long-winded name that happens to be incredibly descriptive. The WebDriver backed Selenium. We have tried to make this bug for bug compatible with the existing Selenium RC implementation, but it is a completely separate implementation. There may be hiccups, there may be places where it doesn't work quite as effectively as it could. If you're worried about this, the best thing to do would be to take your existing Selenium RC tests and run them not with the default Selenium, but with a WebDriver backed Selenium and identify where the problems are. Typically, there'll be a handful of systemic cases that need to be addressed and fixed, and then everything will work. If you've been using the page object pattern, it's easy to avoid this particular problem. You can just fix it within the page object, and then everything will be fine. The WebDriver back Selenium implements an interface from WebDriver called hasWebDriver, which allows you to get hold of the underlying WebDriver instance. What this means is that you can do a piecemeal upgrade of your existing RC tests or page objects to start using more and more WebDriver until the time where either you feel like you've done enough of the migration or you've migrated everything. If you're interested in seeing how that process would work at a large scale, Jason Labour at one of the Selenium conferences gave an excellent talk about how Google had managed this process. And Google had managed this process over Java and Python on one of the largest code bases on the planet. It's a mechanism that works pretty well. So there'll be the WebDriver back Selenium. There will also be the server-side code to provide a remote endpoint for the lightweight SE3 server, the Selenium 3 server. What this means is that if you put the legrc package on the same class path as the Selenium 3 server and you fire everything up, it will be detected, and you won't need to take existing tests that use the default Selenium or the Selenium classes. They can connect using the same connection strings that they always have done, and they will automatically be given a WebDriver back Selenium within the server process itself. That is, if you start your test with star Firefox right now, what will happen is you'll get a WebDriver back Selenium that happens to be based on the Firefox driver. If you use star Google Chrome, you get Chrome. If you use star IE or IE HTA, you'll get one backed by the Internet Explorer driver. The idea with this is that some people distribute their tests, for example, across Selenium Grid or something like that. So sometimes the tests get updated at a different rate to the infrastructure that the test that is being used for running the test. And this allows you to keep the same URL endpoint and the same behavior, but to migrate over to the WebDriver back Selenium. So the legrc package is really the mechanism and the glue that we're offering to enable you to maintain your existing investment in Selenium RC tests, while also allowing us to move the project forward with the WebDriver API. Once again, the project has been recommending for an awfully long time that if you are writing tests, use the WebDriver APIs. And this is the reason why, because we knew that at some point we were going to have to retire the Selenium Core implementation, and that would mean that things that were using Selenium Core would no longer work exactly as they were. So I'm just going to have a sip of water. So while all this work with the one final thing in the before I continue, one final thing in the legrc package is a new implementation of the HTML table runner. So if you have tests using Selenium Core, those original HTML tables, there is a mechanism that will enable those to work. If you just start up the lightweight Java 3 server with the legrc package on the class path and the -HTML suite flag, then you'll get the new core runner, and that will run your existing test. So while all this work on the Selenium underpinnings and the project itself has been continuing, there's been another strand of work that's been going on. In conjunction with the browser vendors, we have been working on a W3C specification for WebDriver. So if you're not aware of the W3C, they're the World Wide Web Consortium, and they're the standards body that shepherd standards such as HTML, HTML5, XML, CSS is also hosted there. So a lot of the specifications that make up the modern web that we know and love. Opera, at the time of the first Selenium conference, suggested that we take the WebDriver APIs and as part of the Selenium project, and we formalized those as a W3C specification. And there were a number of reasons for doing that. The first one is that at the time, lots of companies were shy of open source, and particularly of contributing to open source projects. By having a W3C specification, those companies would not need to use any of the open source code. They could do a complete clean room implementation that would be compatible with everything else out there, because everything would be following the W3C spec. This allowed companies, in particular Microsoft, to start adopting what we were doing. Interestingly, Microsoft's attitude towards open source has shifted radically over the years, and they're now great partners in the Selenium project, and it's always good fun to talk to them. So that's great news. But the specification is ultimately where WebDriver is going. What we've got is, in the Selenium project, the de facto standard tool for doing automation of a web browser, and the problem with that is that the project needs to maintain each of these bindings. And the W3C specification gives us a mechanism to allow the browser vendors to take responsibility and authority for how these drivers work into their own hands. Which leads us neatly onto the future and where the Selenium project is going. So we have Selenium 1, which was the original Selenium core implementation with RC, Selenium 2, which added the WebDriver APIs, Selenium 3, which will remove the Selenium core implementation and make the RC APIs back available, but only in a separate package that you need to take a dependency on, and it will be backed by WebDriver itself. In Selenium 4, we will ship a project that can speak the variant of the WebDriver protocol spoken by the W3C WebDriver specification. There are a handful of differences. The WebDriver protocol spoken by the open source project, the remote protocol, is just JSON and HTTP. And it developed over time in a somewhat haphazard way. It grew organically, just as any project does. The problem with growing organically is there are holes and inconsistencies, and there are places where there are better ways of expressing what it is that we want to do using that protocol. And so what we're doing is, as we're going through and we're standardizing things with the W3C, we are addressing those inconsistencies, and we're working to make things as smooth as possible. The idea is that when we release Selenium 4.0, you'll be able to use the 3.0 client to talk to the 4.0 server, and the 4.0 servers clients will be able to talk to a 3.0 server as well, at least in the early releases. What will probably happen way in the future is we will ship Selenium 5, and that will just be the W3C standard. That's all quite exciting, actually. I'm really looking forward to it. This whole process from getting from Selenium 1 to Selenium 3 has taken approximately 10 years. It's been a phenomenal amount of effort that's been poured in by a group of developers, and the dedication to it is just amazing. But it takes time, it takes effort, and it's a lot to ask open source people, many of whom are doing this because they love the project, not because they get paid to do it, and not because it's part of their job. For example, I'm the lead of the project, and I haven't been paid to work on WebDriver and Selenium for a while now. So, what are we going to do in the future? The first major change that we are making is through the W3C specification, we're allowing browser vendors to own their own drivers. This is absolutely essential because it means that the responsibility for implementing these goes from a tiny handful of dedicated open source hackers to the companies who are most familiar with the way the browsers work. We first saw the benefit of this approach with the Opera driver. Opera software had an implementation of WebDriver that ran with Presto, the old browser engine that used to sit behind Opera, that was fast and efficient and capable. And one of the things it did was it injected events directly into the event queue internal to Opera. So this was proprietary software. There was no way for us to be aware of this event queue or anything like that, but because Opera owned it, they were able to put this extension in and add this capability. And because of that, their Opera driver was fast and stable and a wonder to behold. Interestingly, the Chrome team, having seen this, and also because of the rise and popularity of Selenium, did something similar. So the Chrome driver that you have is a simple binary that knows how to start Chrome in a special mode, and in that special mode you can do things such as inject events directly into the event queue. This is one of the reasons why browsers tend to ship without WebDriver mode being enabled by default. You need to pass in a series of flags, you need to start the browser in a very particular way in order to control it. And this is also why lots of the browser vendors have chosen to only allow connections from localhost in a bid to try and keep things secure and safe. Now, you're doing end-to-end testing, so of course it isn't a problem for you. You have control of your infrastructure. That's great. But by allowing the browser vendors to own their own drivers, what we do is we enable them to do these fantastic implementations that hook into the underpinnings of the browser in a way that as an open source project we would never be able to do. And I think that's going to be essential. The web is becoming more complicated and richer and more sophisticated, and catching up with all of these and attempting to do an implementation that is consistent across multiple browsers is an incredibly challenging task. By moving that workload into a specification, which clearly describes behavior, backed by executable tests, which clearly demonstrate behavior, browser vendors will be able to do the right thing. The other thing that we see in the world is the rise of mobile. If you go back all the years, 10 years ago, when Jason started the Selenium project, mobile phones with a web browser were essentially non-existent. Maybe there were some that used the old WAP protocol, which maybe some of you remember, but probably none of you do, or very few of you do. The concept of the web being on a mobile phone really came to the public's imagination when Steve Jobs presented the iPhone for the first time. It was a revolutionary device, and it meant that people, for the first time, got a widespread idea that they could carry a full web browser in their pocket and be able to do things. Problem is, it's not the same as a desktop browser. There are different limitations and there are different controls. Also different from that, not everything is done through the web browser. There are native applications. Native applications on both Android and iOS are the essentially the way that people access code. But we'd like to be able to control those applications and be able to do automated end-to-end testing of them. Obviously, the end-to-end testing isn't something that just lives on the web. It's something that we want to be able to do for any project we write. If you take a look at how modern operating systems build their UIs, it's very similar in concept to HTML. HTML is a set of nested components, one within the other. And the Selenium WebDriver APIs offer you a mechanism for navigating that tree of nested components, identifying the one that you want to interact with, the web element, and then providing a series of APIs that enable you to interact with that element, clicking, sending keyboard input, so on and so forth. If you take a look at a modern UI of, or even an old style UI of a mobile phone, again, these are nested trees of components, things like grid layouts, table cells, perhaps a web view. And these are arranged in a tree. So you could use the same tree-style navigation that the Selenium WebDriver APIs offer, return something and interact with it. You've got the analogs baked into the underlying metaphors used by both the web and by mobile UIs. And you see this. The most popular end-to-end testing tools for iOS and Android are based on the WebDriver APIs, and they tend to use the remote protocol that's used by Selenium WebDriver. So I'm thinking of tools such as Appium, iOS Driver, the tool released by Facebook, which allows you to control iOS applications, and there's a handful of other ones as well. They all seem to be using the same API, and it's become an incredibly popular way of controlling the end-to-end tests of mobile devices. Now, the nice thing is as well that they work on both normal devices and on the simulators. And the simulators and emulators are the way that you scale horizontally. You can have only sort of a handful of devices in a rack, and they keep on failing and they're rubbish. But the emulators allow you to run more tests in parallel using standard resources that you already have, such as your servers and your laptops. If you go to GTAC and take a look at some of the talks, Google have done some really interesting talks about the work they've done to scale up their mobile testing. So you can follow some of the approaches that they have with a tool such as Appium, iOS driver, the Android drivers, in order to do the things that need to be done. Selendroid is another tool, very popular. As we've been working on the WebDriver specification with the W3C, there have been things that we think should be able to be automated, but which we haven't got time for and we don't have implementations for. As an example, there are what's known by the browser vendors as coat hangers. So a coat hanger is the notification the browser provides when some advanced functionality such as geolocation, access to user media, the web Bluetooth stuff is asked. And typically it's implemented as a little bar that drops down from either the top of the bottom of the browser, going like, would you like to allow Google Chrome, Internet Explorer, Safari to access your current location? And it's generally got a series of options, normally accept, allow, or deny, or some similar language. But sometimes, for example, with the web Bluetooth specification, or some of the geolocation stuff, you might be able to select an input device. So there's a handful of things. They follow a very common pattern, but they're all slightly different. And coming up with a unified API for those would be incredibly difficult because we haven't really thought about this problem before, and we don't know how to do it elegantly. More importantly, getting multiple implementations of this at the same time will be quite tricky. So within the time frame of the original W3C WebDriver specification, we're not going to be able to do that. So what we're doing is we're delaying those for a level 2 specification, which will add additional capabilities. Some of the other capabilities that you might see are, for example, access to the shadow DOM. We haven't yet really nailed that down, and the shadow DOM isn't yet a full specification. So specifying how to test something that isn't a full specification within a formalized specification is a recipe for disaster, chaos, and unhappiness. So what will happen in the future is once we finish the original W3C WebDriver specification, we will then start work on the level 2 process, and that will allow us to release something, get it into browser vendors' hands, and therefore into your hands for your testing, while at the same time allowing us to continue moving forward. So the WebDriver specification level 2 is going to be important, but it's going to be a way down the line. I hope that we should have the W3C WebDriver level 1 specification done before the end of the year. We've recently gone through charter renewal with the W3C, and we need to move things forward. Now, this is where it gets a little bit hazy. The internet keeps on, the web as we know it keeps on evolving. So go back to 10 years ago, 2006, and the web was, you know, CGI, maybe some Java, maybe, I don't know whether .NET had even been released. But basic scripts, and every time you interacted with them, a request would go to all the way to the server, the response would come all the way back, and the entire page would be re-rendered. You have, after that, Web 2.0, heralded by applications such as Gmail and Google Maps, which introduced users to the heavy use of JavaScript in order to improve performance. Interestingly, the XML HTTP request that is the underpinning of the whole of Web 2.0 was introduced by Microsoft as part of the mechanism to make the experience of Outlook on the web better. So XML HTTP request is something of an accident that happens to be incredibly useful, and everyone glommed onto it and took advantage of it. We now have a sort of third version of the web where applications are using HTTP to communicate with backend servers. Again, what we want to be able to do is control those mobile applications using a familiar API. But there's other things happening. The web is evolving. There's the Internet of Things, which is sort of looming down on the horizon and looking ever more complicated and ever more terrifying. And I'm not sure how we're going to do that. You have speech-based agents such as Siri, Alexa, the new Google helper. How do we test those? You know, do we support end-to-end testing with that? Is the WebDriver, is Selenium, is the WebDriver specification, is the Selenium Project the right place for those? We just don't know. And until those things start coming in more widespread use and available to people, we're not really sure how it's going to feel and the direction in which we're going to move. But you know, it's an interesting time that's coming up to us. So in the sort of distant future, I'm not quite sure how we're going to deal with the evolving web, but there's a lot of interesting things coming. So to recap, what is the roadmap for Selenium 3 and onward? Selenium 3, which we aim to release as soon as possible. I think we've done the last 2.x release. I think we're now, the next release will be the beta of Selenium 3. That will drop the original Selenium core implementation. We hope you are using the existing WebDriver APIs. They're certainly the user-facing ones. They are what we've been recommending for at least 3 or 4 years, 5 years. So hopefully those are the ones you're using. If you're not using them, I really hope you're using the Selenium RC APIs wrapped up in page objects. The reason for that is that there will be a leg RC package that you can download, which will allow you to at least compile your tests and get them running. And there will be, I promise you, some systemic problems which should be easy to address. As an example, the WebDriver APIs handle things like alerts reactively. That is, the alert pops up and then you interact with it. The Selenium RC APIs, because they were written in JavaScript and popping up an alert would stop the execution of JavaScript, took a preemptive approach. So what you would do is you'd say, choose OK on the next alert, or choose cancel on the next alert. And by overriding window.alert, that's how they would work. So there are minor differences in the way that things work, but generally they'll be systemic in that way. There'll be a consistent behavior where if you just change it in a couple of places, things will continue to work as they should. So that's 3.0. 4.0 will be where we start speaking the W3C WebDriver protocol. Now the nice thing is that is a under the covers change. If all you're doing is using the WebDriver APIs, 4.0 will be a drop-in replacement. So 3.0 is a drop-in replacement for 2.0, 4.0 will be a drop-in replacement for 3.0. The same user-facing APIs should be offered. We may remove some classes, we may make some minor changes, we may take advantage of the major version number change, but they'll be minimal and they'll be contained and they'll be documented. The difference between 3.0 and 4.0 is far less dramatic in terms of your tests. It's only if you write your own infrastructure, for example, if you're a company such as BrowserMob or Source Labs or something like that, who have their own server implementation, who will suddenly start to need to be able to speak this wire protocol. If you don't care about the wire protocol, it's effectively a no-op change. It will just do exactly what you expect it to. So that's the roadmap. We've got 3.0 coming. That will just be the WebDriver APIs. And we've got 4.0 after that, which will be the WebDriver APIs plus the ability to speak the W3C underlying protocol that's used to communicate with the remote server. But that should be a far less dramatic change than what we're offering with 3.0. And so we reached the end of this talk. Thank you all very much for listening. Like I said, I was planning on speaking for about 45 minutes and leave plenty of time for questions. And I think we are at about that. If you're interested in Selenium, you want to see the documentation, you can go to www.seleniumhq.org and you will see all the documentation there. You can also find us on GitHub. If you want to contribute code or file tasks or issues, you can go to github.com/seleniumhq/selenium. We will be there. I am SHS96C on Twitter, and I am here to answer your questions. So I believe I'm going to be told what the question is. So please, our first question.
Yeah, hi. I will read them out to you. So the first question is, can you hear me, by the way?
I can hear you.
Oh, perfect. Okay. First question, is the Selenium project planning to scale Selenium 3 to interact with standalone applications, for example, Windows applications?
That's a good question. Way back in the day, so I mean, you can already see us doing something like that with mobile applications through, well, it's not us, but people have taken the WebDriver API and the wire protocol, and they've extended it for use of mobile testing. So you can see that with Appium, Selendroid, iOS driver tools such as that. So on the mobile space, that has already happened. Go back to when I was at ThoughtWorks, and .NET 3.0 was released while I was working on a project in Chicago. .NET 3.0 offered a UI automation API and set of DLLs that allowed you to use accessibility APIs through .NET to control Windows applications. I can't remember his surname, but there was a developer at ThoughtWorks India who called Vivek, and I forget his surname because I'm awful like that, who wrote a tool called White. And White was a .NET tool that took the WebDriver, an approach similar to WebDriver, and used those to automate Windows applications. eBay, a long time ago as well, wrote a tool called Twist, I think it was. Was it Twist? I can't remember, I think it was. But eBay had a tool which used the WebDriver API to control native applications as well on Win32. So there isn't a plan within the project to take the Selenium APIs and morph them to address native applications, but there are already other projects that take the APIs or the wire protocol and use them to control existing applications. So the thing that we're trying to do with the Selenium project is keep our focus on automating the web. But there's nothing to stop sister projects or related projects or anyone, in fact, taking the work that we're doing and applying it to other contexts that we're not aware of or that we're not following properly. I hope that answers the question. I'm sure if it doesn't, you can post a follow-up. But I think I'm ready for the next question, please.
Okay, so you mentioned mobile before, and we got a few questions about what are the additional improvements in Selenium 3 for mobile.
So additional improvements for Selenium 3. Selenium 3 has no additional improvements for mobile. The only thing we're doing in Selenium 3, the reason why we're bumping the version number, is because we're removing the original Selenium core implementation, and we're shuffling around some of the server implementations that we have. So that's the reason why we're moving from 2 to 3, because we're making a sort of radical change, and it's possible that some people might find this to be a breaking change, in which case we hope they file bugs and help us move the project forward. The mobile work is mostly handled by the people who are writing mobile implementations. So that'll be the Appium team, the iOS driver team, the Selendroid team. The people working on those things are collaborating together to try and ensure that you can take the protocols, the one implementation, and switch it out for another. And you can see the success of this because companies such as Source Labs, at least for a certain period of time, offered multiple different mobile automation tech tools that you could use, since they all spoke the WebDriver protocol. So within the project right now, for 3.0, all we're doing is we're removing an old implementation. Over time, perhaps particularly as the level 2 stuff for the W3C comes through, we're going to see some more mobile-focused changes. But for now, there's nothing really planned. 3.0 will just be your existing WebDriver APIs, the old Selenium RC APIs available if you take an additional dependency, and the old Selenium core implementation being removed entirely. I hope that's not too disappointing, and I hope that answers the question. But the main key takeaway here is if you're interested in advancing mobile testing, then finding one of the sister mobile projects that take advantage of the WebDriver APIs and building on top of those is probably a really sensible way to go. Obviously, if there are changes on the mobile web that we see, for example, the coat hangers that I was speaking about earlier, or some of the upcoming changes to enable the web to compete more effectively with native applications on mobile devices, then obviously we would aim to support those with Selenium and through the Selenium project, but we need to know what those changes are and what matters to you. Next question, please.
Okay, just to clarify, another question that we got is the impact, if any, that the new implementation of Selenium 3 will have on the current Selenium grids. So if you could clarify.
Okay. For those of you not aware of it, I'm sure most of you are, but just in case, Selenium Grid is an implementation of is a server that sits there and allows you to scale your tests by running many tests in parallel by distributing the driver instances across a grid of machines. The original version was inspired by work at Google called the Selenium Farm, and we have with Selenium 2 a complete re-implementation of that, written by developers largely from eBay. So the way it works is it introduces what in the W3C specification we call an intermediary node. So an intermediary node is one that takes the HTTP request, the HTTP in JSON, and forwards it to another machine. As such, the change from Selenium 2 to Selenium 3, when you're speaking the remote WebDriver protocol, there should be no difference whatsoever. The remote implementation hasn't changed at all. It's exactly the same as it always was. What will happen is when we move from Selenium 3 to Selenium 4 and we speak a different wire protocol, then we're going to need to do some work on grid. But again, if you get your implementation of Selenium Grid from the Selenium project, we will make sure that it works. I think I mentioned as I was talking that the idea is that each implementation is a drop-in replacement. So all you need to do is take your existing dependencies and increment the version number. So when you go from version 3 to version 4, things should just work. And again, as I mentioned while I was talking, the idea is that certainly for the initial versions of 4.0, it'll be forward and backward compatible. That is, a 3.0 client will be able to speak to a 4.0 server, and a 4.0 client will be able to speak to a 3.0 server. So you'll be able to do a sort of piecemeal upgrade of your infrastructure and your Selenium grid without needing to do everything the moment the very first 4.0 dependency appears anywhere in your company. And I think that's important to be able to do that sort of managed upgrade in a controlled way. But for Selenium 3.0, if you're using the remote WebDriver protocols, everything will just continue to work as it will be. So you can have a 2.0 grid chatting with a 3.0 client, it will just work. So, I mean, it's just business as usual is the way of thinking about it. Is there anything else about grid that I can say that's helpful and cogent? No, I mean, you know, the key takeaway here is Selenium 3 is removing Selenium core. It isn't making any other changes to the underlying APIs or project. So the way that things work won't change radically. That major change is already underway. The browser vendors are taking responsibility and control of the WebDriver implementations, and so the wire protocol is a sort of thing that we are standardizing with the W3C, and Selenium 4 will be that standardized protocol being sort of written in stone. But until then, the implementations that I'm aware of all speak the remote WebDriver protocol spoken by Selenium 3 and Selenium 2. Next question, please.
Okay, so given that there are different tools that are gaining popularity, such as React.js, are the upcoming Selenium 3 and 4 releases considering a good way to interact with those tools?
So the frameworks you use to generate the HTML are orthogonal to how you interact with that HTML. What I mean by that is React is an incredibly clever piece of technology. What it does is when you say something to refresh, what it does is it builds a virtual DOM, compares it with the current DOM that it has in memory, and it does a minimal set of changes to the actual HTML DOM in the browser in order to affect that change. And that allows, and the reason it does that is the virtual DOM is incredibly fast, and modifying the underlying HTML DOM itself is a relatively slow operation. And so it's computationally more efficient to model everything, figure out the minimal set of changes, and then just do those minimal set of changes. But once those changes have happened, that's just HTML, that's just you know, normal JavaScript. Facebook have done talks at Selenium Conf about how they use WebDriver for their testing. So we know that Selenium WebDriver is used at Facebook. And Facebook is obviously the home of React.js. That's where it came from. What the question could be interpreted as is, are we going to add support classes that make it easier to use tools like React.js with the WebDriver APIs? For example, back in the day, jQuery used to have a flag that would go that could be monitored to go to determine whether or not an action was still being performed. So if it sent out an XML HTTP request, or if it was doing a transition on the UI or something like that, it would have a count of like how many outgoing things were present. And when that number reached 0, then you knew that the system had reached a steady state and it was safe to proceed with the test. I know tools such as Angular already offer those hooks for people to take advantage of. So if you use Protractor and it's WebDriver stuff, then you are sitting you've already got that implementation. React.js, I'm not aware of anything, and so what you will probably do is take advantage of the wait class that we offer in the support package. in order to do that. And the other thing to do is you can think of the very first talk about WebDriver I gave in 2007 viewed WebDriver as like an assembly language. It was like an underlying building block for doing browser automation. And what you would do is, in your own tests, you would layer on top of it the APIs that were appropriate to the domain you were working in and the skill of the developers you were working with. Now that first talk went all the way up to fit, ironically. But there's no reason why you couldn't do page objects or loadable components or things like that that would allow you to model the interaction with JavaScript-based systems such as React.js in a clean and elegant way. Are we going to add those to the project itself? My gut instinct is probably not. I think what we will do is make it talk to, the best thing to do is, sorry, let me rephrase that. My gut instinct is probably not. And the reason for that is that we don't control the implementation or the releases or the timelines or the technologies used by the tools you're thinking of. The best people to provide that integration hook are the projects that are actually doing the tool itself. So if you needed a hook in React.js, then the React.js guys would be the people that I would talk to about the best way to automate that using WebDriver. Similarly, if you see something in Angular, the Angular team are the best people to talk to like that using Selenium and the APIs that we offer. The project really is a sort of set of building blocks for allowing you to do things. The support library actually began as a response to somebody. People going, I don't know how to do this, it's really difficult. I think it was waiting for an element. And so I quickly threw together like a putative API. It's like, oh, if I was doing it in my project, it would look a little bit like this. The support package has grown somewhat, and I think people tend to rely on it quite a lot, and that's a great thing. But people are also more than welcome to do libraries that build on top of the WebDriver APIs and offer something that is appropriate for the libraries and tooling and bits and pieces out there that they need to get hold of. XJS, I think, for example, is a really good example of a library that would benefit from a good wrapper to make it easier to do end-to-end testing using the WebDriver APIs. But yes, the project itself probably won't write those, but if you find that you need an additional capability from the browser automation in order to try and make that possible and simpler, then that would be something that we would be interested in adding. But I think you've already got, through the use of execute script and execute async script, most of the hooks that you need in order to do the stuff that you want to do. I really hope that answers the question. I realize that I gave like two completely separate answers there. I hope one of them was the right thing. Next question, please.
Okay, so we're really out of time, so we'll make this one the last one. Is there any document or guidelines to write new language bindings to WebDriver?
Oh, new language bindings. Yes, there is. If you go to GitHub and the Selenium Project, I think there's a page on the wiki about how to go about doing this. The simplest thing to do, if I was, so the interesting thing is that the initial WebDriver implementation was done TDD. I was at ThoughtWorks. I'm a big fan of agile software development methodologies. So of course I use test-driven development in order to write the initial implementations of WebDriver. So I would begin with some of the simple APIs, such as get and quit. If you can start a browser and stop a browser and get it to navigate to a page, you have already done quite a lot of stuff. After that, I would think about how to implement finding a web element. And once you're able to find a web element, then probably send keys and click are the next two commands that I would implement. And so what I would do is I would, rather than trying to cover everything all at once, I would do a slow rollout of functionality that allows you to cover what you need to do. Now, I believe that that page is on the wiki at the moment, but that not at the seleniumhq.org, but on the GitHub wiki. I think that information is available. If it's not, we should make it available. But it's been a while since we've seen a new implementation. I think there's stuff for Perl, PHP, Objective-C, Java, more JavaScript implementations than I know what to do with. I don't know what's wrong with JavaScript developers. They love writing new things. C#, obviously maintained by Jim Evans, Ruby, Python. Yeah, I mean, most of the programming languages that I think people are using day to day to do automated testing already have their own binding. But if you need to write your own, then just connecting to a server and sending the correctly shaped JSON is the way forward. By the way, the reason why the protocol uses HTTP and JSON is to make it really easy to write a new implementation in a different binding, in a different client language. Every language that I'm aware of basically has an HTTP library and a library for serializing and deserializing JSON. And so what we were trying to do is lower that barrier to being able to write a new implementation as far as humanly possible. What I would do if I was doing a new language binding is I would try and come up with one that felt idiomatic for the environment and for the language you were writing it in. So, for example, the .NET bindings follow the .NET naming convention for accessing property, whereas in Java they follow the Java naming convention, and in Python they use a sort of Python convention. And you'll see some of the commands, some of the methods with slightly different names and different bindings. And the idea there is that it feels like the binding was written by someone who knows and genuinely enjoys programming in the language that the binding is, rather than trying to have like a one-size-fits-all approach that we could auto-generate. Really hope that answers the question. If it doesn't, then hopping onto the Selenium IRC channel on Freenode and asking for help there is a really great way to move forward, or accessing the Selenium developers list Google group and sending a message out is also a good example of where to get help. Both of those places have some of the developers of Selenium hanging out on there and answering questions, so you can get the most help. But the immediate help will come on the IRC channel. Thank you all very much for your time and attention. I really appreciate it. It's been a real pleasure. Thank you also to Applitools for inviting me to come and talk, and thank you all. I hope to hear from you soon. Take care. Bye-bye.
And so that's all the time we have. Simon, thank you so much for taking the time to give us this really awesome sneak peek at Selenium 3. And of course, I want to thank everyone to join us today. And I hope to see you at our next event. Bye.